In the previous video, we defined computing and computer science, highlighting that computer science involves problem solving, designing solutions, and implementing these solutions through program development for computers. In this video, our focus shifts to exploring computational thinking and algorithms. At the end of this lecture video, you will be able to differentiate between the two types of knowledge, define computational thinking, define an algorithm, and list the properties of algorithms. Computational thinking involves approaching problems in a systematic manner to develop solutions that can be translated into computer programs or actions executable by computers. For instance, in the context of the recent pandemic where wearing face masks is mandatory, imagine being tasked as a computer scientist to create a system that can detect if a person is wearing a face mask using surveillance camera footage. Computational thinking requires breaking down the main problem into smaller, more manageable components for systematic resolution. A solution may be to locate the persons in the video first, find the face of each person, then finally determine if the mouth and nose are covered by a face mask or not. In determining if the person's face is covered by a face mask, precise characteristics of a mask versus unmasked face must be identified and quantified. Each step must be detailed and structured to facilitate conversion into a computer program. To elaborate this concept, let's explore the two fundamental types of knowledge, declarative and imperative. Declarative knowledge comprises factual statements. For instance, a declaration like the World Health Organization has classified COVID-19 as a pandemic falls under this category. Moreover, the statement the square root of x is y such that y times I is equal to x is a declarative knowledge since it also states a fact. However, it does not say anything about how the square root of x is computed. Imperative knowledge answers the question how. The process is described in this kind of knowledge. For example, the square root of x can be computed through the following steps. Start with a guess g. If g times g is close enough to x, stop and return g as the answer. Otherwise, update the guess using this equation. Repeat step 2. Again, declarative statements are statements of fact, while imperative statements are a description of how to do something. Let us consider the following example to differentiate declarative and imperative knowledge. If we want to get the square root of 25, declarative knowledge would say that the square root of 25 is 5 because 5 times 5 is equal to 25. This is a statement of fact. In computational thinking, we need to know how 5, which is the square root of 25, is obtained. In imperative knowledge, we will follow a process in order to get the square root. Take a guess, say 3. Check if 3 times 3 is close to 25. Since 9 is far from 25, we take another guess. Now we compute a new guess using this formula. The result is 5.67. 5.67 times 5.67 is equal to 32.15 and is still not close enough to 25. We need to guess another value using the same formula. The result is 5.04. Since 5.04 times 5.04, which is equal to 25.4, is close enough to 25, we can say that 5.04 is a good estimation of the square root of 25. Computational thinking can be likened to crafting a recipe. Just like in a recipe, the steps or instructions in computational thinking must be precise to ensure they can be executed accurately. In the scenario of calculating the square root of a number, we follow a series of straightforward steps, such as selecting a guess and determine the point at which these steps should conclude, like when we determine that the guess adequately approximates the square root of the number. In the next set of slides, we are going to discuss specifications and algorithms. A specification tells us what we need to do. In our example earlier, we are asked to determine the square root of a number x. A specification usually includes the valid inputs and the desired outputs. An algorithm answers the question, how do we do it? It is a list of instructions that describe a computation. When these instructions are executed given a set of inputs, we will arrive at the desired outputs. In our example in getting the square root of a number, the steps that we have described is actually an algorithm. The algorithm is an example of a guess and check algorithm, which checks whether or not the guess is already a good one and can already be considered an output. More formally, an algorithm is a finite set of instructions that specify a sequence of operations to be carried out in order to solve a problem. Algorithm design is not about solving just one instance of a problem, but solving all instances of the problem. As mentioned earlier, computational thinking is dealing with problems in a systematic manner and formulating solutions that can be translated into instructions or algorithms that can be carried out by the machine. Algorithms have the following properties. Finiteness. An algorithm must be completed after a finite number of operations. Consider the following steps. Take 20 pesos out of your pocket and give it to me, then repeat step 1. The problem with this is it does not have a step that specifies when you will stop taking out 20 pesos from your pocket and giving it to me. An algorithm must have a step that will specify when it will terminate. In our example earlier, we will stop guessing the square root when guess times guess is close enough to x. Absence of ambiguity. Every step of an algorithm must have a unique interpretation. Every time an algorithm is executed with the same input data, the same output data is produced. Define sequence. Each step must have a well-established structure in terms of the order of execution. And lastly, define input and output. The input accepted by the algorithm and the output produced by the algorithm must be well defined. The input is the data presented to the algorithm, and the output is the result of the execution of the algorithm. In summary, computational thinking involves methodically addressing problems for computerized solutions. Declarative knowledge states facts, while imperative describes how to perform tasks. Algorithms follow precise steps for problem solving. They must be finite, unambiguous, follow a defined sequence, and have clear input output definitions.